Hi guys, it's Key. Today I wanted to go over making a quick web server with my library qiweb.h. It's a very simple library. I think the only requirements is that you have OpenSSL and you're gonna need mkcert. So let's get started by making a directory for cd to the website directory like so. And now I'm going to go to my website to get the library at my website qiweb.xyz. Go to the qiweb. So this one's the library. So just copy that. Nice and simple, header only. Very nice. I don't think there's anything about the configuration. So I'll usually put all the config things in the top. So this one's already, it's by default. It's going to have the options for localhost, hosting on your own server with no caching. Nothing needed to be changed there. Leave that. And now we go to the little example down here. Just copy that. Make a main. Put that in there. Now we are going to have to change this to point to the qiweb library we just have. And now the next part is to actually use mkcert to create the certificates. So we can do handshakes over port 443 because usually you're going to want to do HTTP over TLS. So I'm just gonna make a few windows, go back into main, going to use mkcert localhost. And if you don't have mkcert, you can usually, if you're using Pacman, you can do mkcert SYU mkcert. Yeah, this will usually find it. But on Artix Linux, it's not on the repository, so I had to build it from the source. But otherwise, get mkcert however way you can. So now I have run mkcert localhost. I have the certificates in here. And now I just have to change the addresses in here. Localhost for that full chain, and then localhost key, like that. And now we just have to build it. Main.c. We don't need to include the .h. And then we need to link SSL. So that's OpenSSL and link crypto, like that. Now we have our executable. Now we need to run this with sudo because it's going to be running on port 80. Sudo port 80. Now that we have sudo there, we can now call surf localhost, and there we go. It tries to serve whatever was in the options there. So also let's try to go into website main. We can change whatever it serves in here. Yes, all right. So that's how you get it up and running within just a few minutes. It's very simple. You just need to make the certificates, copy the header only library, copy the example, and then you have a web server that's running. If you want to have it running on the internet, you will have to do HTTP challenges to prove that you're going to first need to get a domain name, and then you're going to have to do an HTTP challenge, which will then get you the certificates. But that's not too complicated. I might make a video about doing that. It's quite simple. But I'll go over how the library is kind of used. So I'm just going to start with the main. function. This is the entry of the executable. So it starts here. It grabs the certificates, and then it opens up port 80 and port 443 for web traffic. And then this is just listening for the file descriptors and seeing if there's any data available, and when it is, it will actually allocate some memory for the structure, one of the 3 structures that are provided in qiweb, mkcert.h. So these are all the structures provided. First one is the client info, so it stores information like the file descriptor. Then it's got the SSL context pointer, so you can edit your own SSL settings, which version of TLS you want to use. Maybe, I'm not sure what other options there are, but I know you can change the version of TLS. And then the SSL object, which is for each unique connection, and then also stores the IP address of the person connecting. It's also got the port that they're using to connect to you, and it's also got the port that you're receiving them on, so you can tell if it's port 80 or port 443, which is handy if you want to maybe leave the option of port 80, but most web servers will redirect to port 443 anyways, and that's also an option. Both of them are options that are available when using qiweb.h. And then it's just a little bit of logging here, and then we actually dynamically create threads in this example. You can use a different library to handle your own threads and dispatch the function that will handle the client, but use whatever way you want. And then once it gets handed off to the thread, is this the th worker function. So you can add whatever function you want, but this is the th worker function that I've chosen to name like this, dispatched by the pthread create. So this receives the client info pointer passed to it, and then depending on if it was received on the SSL port, it will do a TLS handshake. Now, even if you want to force everyone onto port 443, you do need to check here that it is SSL port to do the handshake, because if you force port 80 to do an SSL handshake, you can't even redirect them. So this needs to be here whether you want to force port 443 or not. And then I have a for loop for keep alive behavior. So you can use the same connection to send multiple requests, but you can choose to not do that if you don't want either. You can just choose to close it after every single request. But this is how the example is. And so you set up the 2 other structures included in qiweb.h. So you have the HTTP request, which in here it just stores some pointers into the a buffer. And then you have the HTTP response, which is just a whole bunch of settings about the headers to be sent and what kind of data is going to be sent in the response. So, and then we have 2 buffers. So this is the request buffer that's going to read the data from that the client is sending into this buffer, and then we have the response buffer where we're going to format our response in a char buffer. So we use recv HTTP to receive the response, loads it into the request buffer, and then we have parse HTTP to parse through the request buffer and load the information into the HTTP request, and then you can check for individual headers to modify the behavior of your server. So here I'm checking if there's a connection header, and then I'm also checking for an expect header and a content length header. So you can, depending on what kind of headers you receive, you can change your response. So you can see here, if I receive the connection close header, I'm just gonna change the behavior of the response to say close the connection. So there's that. Whole bunch of notes about HTTP 1.1. And if you choose to force HTTPS, that would be a block like this. So if the SSL object is non-instantiated, as in we are on port 80, because if that object would not be null if we went through this block of code, or we went through this SSL handshake, then that SSL object would not be null. But if it is null, then we're going to force them onto port 443 by printing into a char buffer the URL with HTTPS, and then it's going to put that into the response, HTTP response, and then it's going to format the it's just going to format the response. And then this is actually one big if-else loop. So you can only choose one of these. We're just going to format the response in a certain way, and then in the end, it's going to send the response, and then depending on whether the connection was noted to be closed, it's going to break out of the loop and it's going to close the connection. But if it was not closed, as in keep alive, then it's just going to start over again at the beginning and keep listening for more responses. So that's the very basic behavior. And you can see I have here, this is actually what is being sent. So it's actually looking for an image, and it has a p tag. So if we look at, what is it? This right here, which is what we were requesting. If we actually change this right here, will show up there. So let's try that out. So I'm going to put an header tag this time. Header, this is ugly, I'll get rid of it. But yeah, you can definitely send images as well. So I'll go over that right after I throw an example of changing this. So then I'm going to write gcc main.o lssl lcrypto this dot sudo /a out, like so, get it running. And now let's try refreshing with Control R. So it actually tried to force you onto port 443. So I'm just going to disable that for now. Like so. Okay, just going to disable that. So is that fine? Oh yes, I'll have to comment this out too. Okay, so we're just going to rebuild it again, like so, and then refresh. I wonder if I have to delete the cache. So I'm just going to delete the cache. It's localhost. Like that, yeah. Now we see our H1 header. Very nice. So now, if you want to serve files, let's say we have some kind of image we want to serve. So I'm just going to steal an image. Let's see. Let's take the logo here. Just have an image, so we want to serve that image over there. Oh, should go back to here. So in order to serve this image, we're going to let's see, yes, by default it'll look for a public file, public directory. So we make public, move the image we want to serve into public, like so, and then it's going to request into public. So let's look at the HTML we're serving again. Right here, put an image tag, image, specify the source, /public/ like that. I think I can actually do this like so. Let me see if that works. Oh yes, you also need to break out of here because like that. And now let's see if we can build it again. A.out, sudo main A.out, like that. And now refresh. There we go. Now we have the image loaded. Very nice. And you can also have, you can also check what kind of method is being used. You can check the route. You can also do a redirect. So I'll give an example of the redirect. So this is going to redirect back to the default. So this is going to be surf localhost redirect me. There we go. It's going to redirect me, but right back there. And then if it's not found, it'll just send a 404 and it'll close the connection, like so. So surf localhost not found. Yeah, not found. Very nice. And it's that simple. In 200 lines of code with this library, you can have a web server running in just a minute with very customizable behavior. So let me know what you guys think.